Section 2.1, Working with Fractions Applications. All right, an apprentice carpenter measured the length of a 2 by 4 as 8 and 10/16 inches. Express this measurement in lowest terms. Okay, so the 8, that's already done. The thing that we actually have to reduce is this 10/16. There's a couple of ways of looking at this. One is, what is the largest number that I can divide both into, the 10 and the 16? It's referred to as the greatest common factor, but you don't need to know it's called that. But that's what it is. Greatest common factor is basically the largest number you can divide into both. The largest factor, the largest number you can divide into both. And that's actually what we're looking for. We're looking for what number can I divide both into a 10 and a 16. Can I divide 1 into both? Yeah, but that's not very helpful, right? You're just going to end up with the exact same thing. Well, what about a 2? Well, if we divide 2 into both of these, we get a 5/8. Now, you know you're done reducing or simplifying a fraction when the only thing that you can divide into both the numerator and the denominator, the top or the bottom, is a 1. And since the only thing that I can divide both into a 5 and an 8 is a 1, we know that 5/8 has been simplified. So we're just going to tack it back onto the 8 as 5/8. And there you go. Okay, so let's try the next one. My fraction bars got eaten up. I apologize. Let me put the fraction bars back on there. Okay, the numbers 79/25, 63/20, 41/13, 25/8, and 157/50 are all reasonable approximations to the number pi, which is the largest approximation, which is the smallest approximation. There are different ways of comparing these, but probably one of the easiest ways of doing it would be to get an approximation using your calculator and then comparing the decimal approximations of these. That's probably the easiest way to deal with it. So all you would do is you type these into your calculator just the way I have and put equal. Some of you might have to push a decimal button depending upon the calculator, but you will be able to find an approximation button somewhere, and what it will do is it'll spit out a decimal approximation. And then what you would do is you would compare those decimal approximations. Okay, using a calculator, I found out that 79 divided by 25 is 3.16. 63 divided by 20 is exactly 3.15. 41 divided by 13 is approximately, which is where the squiggle comes in. The other ones are exact, but this one's an approximation. 3.153846, and it just kind of keeps on going. ... 25 divided by 8 is 3.125. 152 divided by 50, 157. 157 divided by 50 is equal to 3.14. Okay, now this is how we compare these. We just go straight across because they want which is the smallest approximation, right? So, in this case, we start at the leftmost number and they're all 3's, right? So 3 is not going to help. They all have a 3 there. Well, that doesn't help, so that's equal, right? So we move on to the next number to the right. We have a 1, a 1, a 1, a 1, and a 1. Well, those are also equal. So even when we get to the 10th place, they're still equal, so that's not helpful. Now, we're finally to a point where they are different. We have a 6, we have a 5, we have a 5, we have a 2, we have a 4. Okay, now of those, what's the smallest one? Well, the 2 is the smallest one. The 2 is the smallest one out of all those. So we have a nice 2 here, right? So the 2 looks like it's the smallest one. So we have a 6, 5, 5, a 2, and a 4, and the 2 is the smallest. So what that means is the smallest one of these is this, which means this fraction, that 25/8 is going to be the smallest approximation. So the answer to this one is going to be 25/8. There we go. Okay. Is it possible to have a 3/8 pipe with the inside diameter? All right, let's try to check it out, right? And this is, I obviously left out my line right there, my bad. Inside diameter of 16 inches. Well, let's look at the picture. So they're basically saying that from here to here, right, from here to here, you have 3/8. That whole entire thing has 3/8. And what they're saying is it possible to have 3/8 pipe with an inside diameter of 11/16? So they're really saying, well, is that right there equal to 11/16, right? Now, how would you know? Well, basically, if the inside diameter is smaller than 3/8, that's okay. But if it's larger than 3/8, that's not okay. Okay, you can't have an inside diameter greater than the outside diameter. That doesn't work that way, right? So what you're going to do is you would find a decimal approximation like before, so that'd be 0.375, and then you would have 11/16, and 11/16 is approximately equal to 0.6875. Okay, there is a technical way of reading this, which is the 10th place, 100th place, 1000th place, so that's 375 thousandths, and this would be the 10th place, 100th place, 1000th place, 10,000th place. You would read this as 6,875 10,000ths, but I'm not going to worry about that. We'll just say point for now. So as you can see, it doesn't make sense that this, right? So this right here is equivalent to 0.6875, which is obviously bigger than 0.375. So you can't have an inside diameter larger than the outside diameter. That doesn't work. So the answer to this would be no. That is not possible, right? Okay, let's try the next one. A printer has 18 rolls of newsprint in the warehouse. What fraction of this total will remain if 3 rolls are used? Okay, so we want to find what fraction of this total will remain. Okay, well first let's figure out how many in absolute terms will remain, right? So we had 18, we used 3, or took 3 out of the warehouse, right? So that leaves us 15, okay? So that's in absolute terms how many remain. So how many, but they don't want to know that. They want to know what fraction of this total will remain. So of the total, what fraction of the total will remain? So what you're going to do is you're going to put the number that remain, and you're going to put it on top of the original amount right here. So you're going to put that on the bottom right there. That's the original amount. So it looks like the fraction that remains is 15/18. Now normally that would be a perfectly valid answer, but whenever you have an answer that is a fraction, you are expected to simplify it. So if there's anything we can divide into the numerator and the denominator other than 1, we are expected to do so. So what do? Well, I can't divide them by 2. 15 divided by 2 is 7.5. 18 divided by 2 is 9. I didn't get an even number on top, so we can't do that. Well, how about 3? Will 3 go evenly into both? 3 does go evenly into both, right? So we could say 15 divided by 3 is 5, and 18 divided by 3 is 6. So it looks like what fraction of this total will remain? Well, it looks like 5/6 remain. 5/6 remain.